Welcome to this UASMaster video tutorial. The video shows the mesh generation workflow with UASMaster version 9.1. As in the previous video shown in the introduction, we assume you already have completed the georeferencing with acceptable results for the adjustment and orientation of the photos. The mesh generation is typically extracted for visualization projects. Often we have an object of interest, so we fly not as an area mapping project and want to cover as much as possible space, but we fly around an object that we are interested in, and we fly with different heights and scales, and therefore our photos have different ground sample distance. Most of the planning software you have for the drones have good software planning for area mapping, and also you can just run a circle and define an object in the center that you want to fly around, but coverage for these objects and also quality is in most cases not given, so you need experience how to define your flight circles, your distances, and also at what degree you always will take photos. In the demo data that we use here, the training data UAS3D, we can see here a castle, an older one, and here we see it was flown with 2 circles and on different flying heights. We can also see here that some of the photos are more closer to the object, some photos are further away from the object. We also have a couple photos here just looking nadir to the castle, and also with different angles they are looking at the castle itself. For example, here at every 10 degrees one photo was taken, so if we have 360 degrees for a circle, we have about 36 photos in this circle, and then we have again 36 photos in the lower circle. In general, we recommend to have a very large overlap between the photos. And depending how complex the structure of your interest object is, you even can consider to fly with even more photos during a circle. So instead of 10 degrees, that you take every 5 degrees a photo. So you would then end up with about 72 photos in one circle and 72 photos in the second circle, just that you have more views for the point cloud generation, and also later on from there to generate the mesh. In the surface generation for the mesh generation, we are using the model type Surface SGM 3D, which is for our close range projects, which is the training data UAS3D, the only option that you have here. Mainly, as mentioned, this is not now interested into area mapping, but into a interest object, into a close range project, and therefore we assume you always will have here oblique images. In the previous video about area mapping and true orthophoto, I mentioned that we are doing some filtering on the point cloud and also some edge enhancements. This is not part of the SGM 3D algorithm, so we will not automatically also extract true orthophotos for this SGM 3D process, because we assume you have oblique images and you are not just looking straight down. And true orthophotos typically represent an area, a map, and in our case with an object, we don't have a map. We have facades from different viewing angles, yeah, from north, south, east, west, looking down, looking from the side view, perspective views. So therefore, the true orthophoto is not our main target in our close range project. Our main output targets will be the point cloud and the mesh. And therefore, to have a nice homogeneous mesh, which is a textured mesh with using image content, we also recommend to run the radiometric optimization. I can just show it here. Here we do some radiometric corrections on all the photos. It will use the intensity, color information, and also the brightness information. It will check for vignetting in the photos and automatically make corrections to all the photos, but not in a physical way. It will store them as metadata, as RDX files, which are stored in the same folder as the photos itself. So I will run it here and just make a speed up of the video. Here we go. We finished our radiometric optimization and we can go to the surface generation. In the extraction level, we can select on which pyramid level the point cloud generation will be processed. So in high, we are using a 1 to 2 level photo for the point cloud extraction. In medium, a 1 to 4 pyramid level, and in low, a 1 to 8. This is for the acquisition of the point cloud data. When you run the extraction level on high, you will need to have at least 16 GB of RAM. If your computer does not offer 16 GB, you have to reduce the extraction level to medium, where you will need to have at least 8 GB of RAM. In my case, my computer only has 12 GB RAM, so I will run the extraction on medium level. The extraction of the point cloud is running the semi-global matching, where we can define for each single point in the point cloud how many stereo models have been used to extract the point. The minimum number of models is 2 for automatic. In the SGM 3D and with close range, we strongly recommend to have enough overlap to at least keep these minimum setting or this automatic setting of 2. We even would recommend, with our experience, that you even have more overlap, so that you can run with minimum number of models 3 or 4. Here we can still see a large increase of quality in the result. We have a less noisy point cloud, which will create an even better looking point cloud and therefore a digital surface model, or a DOM as we call it. And this will then extract a better model where we can then run a triangulation on top of it, the mesh. And in the mesh with these triangles, we will then extract for each triangle the image texture from the photos. And this will then create also a better looking textured mesh. As mentioned before, to achieve this, you will then have to fly perhaps more than every 10 degrees a photo in one circle. So instead of having 36 photos in one circle, then you would need to have 50 or 70 photos for one circle. And also perhaps not just fly with 2 circles, but to fly even with 3 or 4 circles, or even to combine to have 2 circles, and additionally also to have a flight pattern like an area mapping on top of it, so that you have then straight looking lines going on top and then some circles around the objects. In our case here we have a very straight looking castle with the walls having not complex structure. So here we can easily increase the minimum number to 4 models, and we will still have enough points covering these parts. And typically we say to use the twice as large value for maximum. So when I use minimum with 4, I will increase this value to 8 by default, or the automatic value is 5. So we can here extract easier points. In our case, some of the photos, they are looking not only on the castle, but they are looking into the background, and we can see the sky. And therefore we will use here this low textured area filtering. This is an image analysis algorithm that looks for sky areas or low textured areas. It will mask them out, and then we will not even try to extract a point cloud in these areas. We have here a medium amount of texture, of sky texture in the background. Therefore I will leave here the default setting. If you have very oblique image looking photos which are seeing a lot of sky in the background, then you can increase this to high. Or if you have only a couple images looking in the background to the sky, or perhaps you have some water area in the background, then you can keep it to low. Or if you don't have any sky, then don't use the filtering, so you will not mask out areas that you will need perhaps. All these settings here are just for the point cloud. Then we have here a second output part, which are the meshes, and we are here dividing this into 2 different types of meshes. We have a mesh that is generated for the whole project in one single file. So this is then possible as a OBJ or as an collada output. And then you see here, this OBJ also exists here in a LOD mesh format, but this one here is now tiled. So we cut the whole project into blobs, and these blobs then are always calculated seamless to each other. So we cut this into 400 by 400 or 1000 by 1000 or 2000 by 2000 pixel sizes, and therefore we can then handle larger areas in a good way. Typically I would recommend just to run the LOD meshes, and typically always with the OSGB. We are offering for this format a small free viewer that you can download from our download web page, and you just need to register. After you downloaded the zip file for the viewer, you can take a look into the README file, which explains how you can use it. The mesh itself, it's like a triangulated mesh, is not including the texture. At the beginning it's just extracting from the point cloud the mesh. There are some corrections done during the process to eliminate extreme errors, and also to remove some peaks, and also to look for when you have multiple models looking on one point, which one of the points fits the best for our point cloud, and then from the point cloud to the digital object model, to the DOM, and then from the DOM to the mesh. But when the DOM is then created, we can look at the triangle itself, and we project it back into the photo, and then we take from the photo our photo content.
which is now radiometrically optimized. So hopefully then we have a homogeneous radiometry for our mesh. And this will be done by saying provide texturing for the generated mesh. And this is then the colored mesh. If you don't have this, then you will just have a shaded relief on top of your mesh, and which is still then showing you the model in a perspective view. But with the texturing, of course, this is looking much nicer. As mentioned, the texturing for the generated mesh is going to the original size of our photos, and therefore if you activate this function, it looks much better, so I would recommend it. But it's also the most time-consuming part of the whole part. So I would say here 40 to 50% of the time is going into the texturing in our whole process here. The mesh itself is also a time-consuming part, and we will look then in the end on our statistics, and we can then see how much time was spent for this part. It is also possible to output multiple formats, but of course this will take all the time in a similar way like extracting the texture and converting it to the format that you need. Typically they have different data structures, so we need here also to take care to provide them in the right way. In our experience, you have to be careful about standardization from the different formats. So not every wavefront OBJ format is the same as the next one. It depends where you define your local coordinate system, where is your X, Y, and Z axis pointing to, and there are also much more things to be considered in this whole process. So therefore, unfortunately, we cannot here go through all the cases, and that's why I also want to recommend the OSGB format, because we can run it with the free viewer from our download page, and so you will always be able to visualize it. In case you want to run through to the internet on a web-based structure, then we strongly recommend you to use the Cesium. Here you would need to go to the page from Cesium. They are offering a large package also for visualization on the web. I will start now here the process, and after it's finished we will then take a last look at the result and take here some views on our output format. Here we go with our processing. It's done. So let's take a look now at our output folder. So when we open up our project, I generated here a subfolder mesh generation for the video, and here we have now the Pointcloud that is written directly to the project folder. Additionally, we have our temp folder, which was defined in UASMaster here in the options preferences. You can define your working directory, and here it's defined for us in the project directory. So here we will define this temporary folder. By default this is set here to systems temporary directory, or you can also define your own directory where all your results would also be written. But be aware, the temp folder always will be overwritten from step to step. So that means if you run the 3D reconstruction, then the temp folder is cleaned up and filled with the 3D reconstruction information. If you run the surface generation, again the temporary folder is cleaned up and filled up with the surface generation files. In our case here,
we have now this UASMaster _engine_temp folder, and when we open it up, we can see here our log file. Here it's more time-based log file explaining all the different steps that have been done. And then we have the folder called 21-Pointcloud, and here we want to take a look into this one at the Trimble report log file. And as mentioned, we want to take here a look at our processing times, which are at the end of this log file. And as mentioned, the texturing part is taking the most time. So we see here the 3D mesh without the texture, just the triangulated mesh, is 11% of the time, so 21 minutes, as we run this on the level of detail 2, so pyramid level 2. So we can see this here on the upper part. So here we see the pyramid level 2 was used for the point cloud generation. And then the texturing, it's more time consuming, and here it takes even 64% of our time. Also, we can see our manual settings here that we defined to have a minimum fold of 4 and a maximum model fold of 8. So this is then also stored here in this report file. Looking more downwards in the protocol, we can also see that our ground sample distance approximately is 2.2 centimeter for our data itself, and the tile sizes for our project here are 5.5 meters by 5.5 meters. Okay, so let's take a look also at the result from the mesh. The mesh we can see is in the subfolder 3D-mesh, and we defined for output our OSGB. And so here we have the folder OSGB. If you would additionally select to extract an OBG or Collada export, then you would have here additional subfolders for each format. And the OSGB is then defined in this 5.5 meters by 5.5 meter tiles. These are exactly these subfolders here. So each one represents one tile of 5.5 meters. And then when we scroll down, we see here a file called main OSGB. This one is the organization file, which we will then use for visualization with the OpenSceneGraph Viewer. If you want to access the OpenSceneGraph Viewer, we are offering here a free simple viewer on our download page. So here you can go to imaging-download. You will need to apply for a login if you don't have one. If you have one, then you can log in. And after you logged in, you go to the info tab, product downloads, and then in the third-party products, you will find here the OpenSceneGraph as a zip file. You can download this zip file and then extract the zip file on your computer. After you extracted the zip file, then I can show you how you can use it. I will just show it then this here on my computer here. So I copied it to a folder that I can use. I will just extract here this part, and then after the extraction is done, we can open the OpenSceneGraph folder, and you can find here this README file text, and it mentions already all you need is to run this here with this part. So we need to know the path where our reader is written, and we will generate a bed file for this. So I will just here copy this part here, say copy, then I here close this part. I will go to my data, and in my data folder, let me see where it is here. Oh, I close it I think here, so here it is, mesh generation 3D mesh OSGB. I will here create a new text file, and I call this one here video OpenSceneGraph, and then I will just rename it here VAT, and then I will edit this one here and enter now this path, and all I have to change now is here where can I find this one, and of course I can find it here in my part here. So I just here take this path, copy, and then I exchange this here. I removed the backslash, not a good solution. Here it is. Okay, and then hopefully this will now make it. Let's see, file, save, and then we can here double click this one here, and then it will find automatically the main.osgb part, and then it loads in the free viewer your mesh, your textured mesh of our result from the product. We can see here there are even more data extracted here in the lower part. We are only interested into our castle. When you hit the H button on your keyboard, then you get your shortcuts. Typically with the L button, it's a very important one. It lightens up everything. With your wheel mouse, you can zoom in and zoom out. With your left mouse button, no, middle mouse button, you can pan. And if you want to get a higher resolution, because this is the level of details, you can use the, not the backslash, but the slash button. And when you hit this multiple times, then this will increase the resolution. And then you get the highest resolution part from your data with the highest texture part of it. And then when we now zoom in, all of a sudden it's not looking so bad. It's looking very nice with a high textured part. I hope for the viewing part this helps now. And if you want to use your Pointcloud data, I will just close the viewer here. You can also run with TBC the whole part. So you can go here to your project, and this is then done with also send to. Yeah? So export is really just when you need a third-party product, not TBC, and send to is then really sending this data to TBC. You can export also your ground control points, but I will not do this. I will just export the point cloud. And then we say that we want to run Trimble Business Center. You need to have Trimble Business Center on your computer installed. And it is supporting now with the new version 5. And so we can send it, and then it opens up TBC and directly loads it. I have on my computer TBC 4.1 here installed, but it will also run with 5.0. And then after the Trimble Business Center verifies the license and also receives now our data, then it will ask to apply to import the data into TBC. And until this happens, I just pause here the recording. To import the data, we will define in Trimble Business Center a new project. And in this new project, we will define here a blank template where we will now define a UTM-32 North coordinate system in which the data can then be added for our visualization. So we will go here to the unnamed project settings, and in the project settings we can go to the coordinate system and define here that our coordinate system will be a WGS worldwide UTM-32 North. So this is then our coordinate system, and then we can go here into our process view and accept now the import of the data into this coordinate system of TBC, and then we can see our point cloud in this coordinate system. The import is finished, and then we can go into our plan view, and here we can then make a zoom extend. Here I think this is this here, and there we are. We have here our data, and then we can also use here a 3D view for this part. So I'm not a good TBC user, you know more than me perhaps, but I think this is this 3D view here. And then we can here rotate our view and take a look at the data from a perspective part. So here we can then with the right mouse button pan, and with the left mouse button we could have selected, well, not a good idea, and with the middle mouse button I assume now, yes, here we can then rotate the data. With the wheel mouse we can zoom in to our point cloud, and here start to do our TBC processing. I hope this helps you to work with close range data, so with the point cloud, with TBC, and with the mesh data with the simple OpenSceneGraph Viewer. Thank you very much for watching this video tutorial, and see you. Goodbye.